Hi, I'm Miss Hall, and this is Lesson 71, Angles in Standard Position, Coterminal Angles, Converting Between Degrees and Radians. So in this lesson we have 3 topics and 3 examples, beginning with angles in standard position. In a coordinate plane, an angle can be formed by fixing one ray, called the initial side, and rotating the other ray, called the terminal side, about the vertex. An angle is in standard position when its vertex is at the origin and its initial side lies on the positive x-axis. The measure of an angle is positive when the rotation of the terminal side is counterclockwise and negative when the rotation is clockwise. The terminal side of an angle can rotate more than 360 degrees. And there is a diagram. And the only thing I'm going to add to the diagram is the quadrants of our coordinate plane. So we have quadrant 1, 2, 3, 4. And in example 1, we're going to draw an angle with the given measures in standard position. So I'll begin by drawing my axes, and I'm going to label the degrees. This is 0 degrees, 90 degrees, right, because you have a right angle, 180 degrees, and 270. Now my angle in standard position, I'll draw it in purple. This is the initial side. I'm now going to rotate my terminal side 240 degrees from the initial. So 240 degrees positive is going to be counterclockwise. And I know it's going to end up in quadrant 3 because it's more than 180. Let me see how much more than 180 it is. I'm going to do 240 minus 180, and I will get 60. So it is going to be in the third quadrant, roughly there. That is 240 degrees. And I know that this piece is 60 degrees below 180. Let's do this again for 500 degrees. 0, 90, 180, 270. Okay, so this is my initial side. To go around 500 degrees, that is more than once. So I'm going to take 500 minus 360. So I'm going to go around once, which is 360. I'm left with 140 degrees. 140 minus 90 is 50. Okay, so this is going to go all the way around 360, and then 140 will take me to about there. And this is 500 degrees. Yeah. Finally, negative 50 degrees. Right? We have 0, 90, 180, 270. We have the initial side, and we want to go negative 50, so we're going to go clockwise. And since this is 90, it's a 90 degree angle, I know I'm going 50 degrees, so it's going to go a little bit more than half. Then I'll draw the terminal side, and this is negative 50 degrees. Topic number 2, coterminal angles. In example 1b, the angles 500 degrees and 140 degrees are coterminal because their terminal sides coincide. An angle coterminal with a given angle can be found by adding or subtracting multiples of 360. In example 2, we're going to find one positive angle and one negative angle that are coterminal with negative 45 degrees and 395 degrees. So you don't need to do a drawing, but it helps me visualize what's going on. So we have negative 45 degrees is the given angle. This is negative 45 degrees. So to find a positive angle that is coterminal, has the same terminal side, I am going to find out in purple what is this angle, right, that goes around in the positive direction. So for that, I'm going to take 360 plus a negative 45, and I will get 315 degrees. So 315 degrees is coterminal with negative 45 degrees. You'll end up at the same angle. And now I need to find a negative angle that is coterminal. So now I'll find one in, that's not helpful, in green. And for it to be negative, I'm going to have to go in the negative direction, and I'll have to do this more than once. Right, I'll have to go negative 360 degrees plus negative 45. So negative 360 degrees, negative 405 degrees. So that green one is negative 405 degrees. Technically, you don't need the drawing. You can just add 360 or subtract 360. But the drawing is helpful for me, so I'm going to keep it in. Okay, B is 395 degrees. So 360 would be the full way around, and this is 35 degrees more than 360. So it is about there. And this is 395 degrees. So if I want to find a positive angle, I'm actually going to take 395 and subtract 360. What if I don't go that extra loop? What if I just go up from my initial side? And that would be 35 degrees. So an angle of 35 degrees would end up in the same spot with the same terminal side. And then to go negative, and I'll say 360 is the full way around minus 35, and that is 225. A negative, it's not 200, negative 325. So I have my initial side, and if I go negative 325 degrees, I will end up with the same terminal side. Finally, topic 3, converting between degrees and radians. In examples 1 and 2, you've been given the angle measures in degrees, but there's actually another way to measure angles, and that is using radians. So it's important for you to know how to convert between degrees and radians. And what you need to know is that pi equals 180 degrees. And that's where we get these two ratios. So when you're going from degrees to radians, you take pi, you multiply by pi over 180, and radians to degrees, you multiply by 180 over pi. And you'll see why in example 3. In A, we are given an angle in degrees, 120 degrees. And so to convert that to radians, we'll want to multiply by the ratio where degrees is in the denominator and radians is in the numerator. And it is pi radians to 180 degrees. And now we can multiply and we'll get 120 pi over 180, which is the same as 2 pi over 3. So instead of saying 120 degrees, you could say 2 pi over 3. We'll do this one more time. Now we have b, which is negative pi over 12. And here we're given the measure in radians. So to convert to degrees, we need to multiply by our unit ratio when radians is in the denominator and degrees is in the numerator. It's 180 degrees to pi radians. The pi's divide out, and I have negative 180 over 12, which is negative 15 degrees. Okay, so final thing you're going to start seeing is that this is 0, 90 degrees, 180, and 270 in degrees. This is also 0 radians, pi radians, pi over 2, and 3 pi over 2 if you do the conversion. So we're going to start to see degrees shifting into radian measures.